welcome to our last topic in this unit, which is writing word equations. Your periodic table will be very helpful in this. It's a combination of some formula writing and balancing, kind of everything we've done in this unit. First, you're going to have to go through and identify what chemicals in the reaction are going to need symbols. I kind of like to go through and really box these in so I can tell what I'm actually going to be writing formulas for. So I have solid nickel reacts with oxygen gas. Actually, to be consistent, I'll just box in oxygen to form nickel 2 oxide. So now I'm going to go and write out each of those chemical formulas. So nickel is Ni, oxygen gas is O2, and we're forming nickel 2 oxide. So it's going to be Ni plus 2, O negative 2, or NiO. Remember, you have to be sure to do any crisscross that you need to do in this compound. We had a metal and a non-metal, and oxygen, we have to remember that that's diatomic, so there's a lot of stuff you need to think about. Then we have to figure out where our plus signs and our arrows and things go. Reacts with gets a plus sign, and to form gets an arrow. It's also nice to go through at this point and see if there are any phases you need to indicate. So solid nickel, oxygen gas, and solid nickel oxide. So we're going to add in our plus signs and our arrows. Now we go ahead and we make sure that this is balanced. So we got 1 Ni, 2 O's, and 1 O. So I'm going to put a 2 in front of this nickel oxide. And I'm still going to need a 2 over here. And everything balances out. Next example. Solid, oops, that's the same question, sorry. Sodium perchlorate is decomposed into, that's actually going to be our arrow, sodium chloride and oxygen gas. So sodium perchlorate, got Na. Perchlorate, you're going to have to go to reference table E for, even I have to look this one up, not one we commonly use a whole lot. So perchlorate is ClO4. Na is plus 1, ClO4 minus 1, so those actually will cancel each other out. That's a nice simple compound for us, NaClO4. Getting decomposed into, that is a solid. You don't always need those symbols. They're not given to you. I just kind of like them. Into sodium chloride, Na plus, Cl minus, so that's NaCl. And oxygen gas, we have to remember O2 because it's a diatomic. So next we're going to go through and we're going to make our balancing table. 1 Na on each side, 1 Cl on each side, 4 O's and 2 O's. Pretty easy fix. Stick a 2 right there, and we're all set. Solid zinc is reacted with, that's going to be our plus sign, hydrochloric acid to form zinc chloride and hydrogen gas. So we've got zinc plus hydrochloric acid. This is actually given to you on a table of common acids and bases, or a table of common acids, which is table K. Hydrochloric acid, HCl, AQ. This is going to form zinc chloride, Zn plus 2, Cl minus 1, so that's ZnCl2. That'll probably be an aqueous solution most likely. Well, if you called it a solid, it wouldn't be the end of the world. And hydrogen gas, which is a diatomic, so it gets a little tiny tube. got one zinc on each side, one hydrogen, two hydrogens, one Cl, two Cls. So all I need to do is put 2 right there, and that reaction is all set. Got potassium carbonate and calcium nitrate react to form potassium nitrate and calcium carbonate. Lots of good formula writing in this one because we've got a lot of crisscrossing. So we're going to start with potassium carbonate. So potassium is K plus 1 charge. Carbonate is CO3. And carbonate has a -2 charge. So this is going to become K2CO3. We're going to react that with calcium nitrate. Ca's got a +2 charge. NO3 has a -1 charge. So we're going to bring down that 2 when we crisscross, and we're using parentheses here. And we are going to be forming, move that guy over a little bit, we need a little room. We're going to be forming potassium nitrate, K plus 1, NO3 minus 1, so that's just KNO3, and calcium carbonate. Calcium's +2, carbonate's -2. So we're going to go ahead, KCO, CAN, 2 potassiums, 1 carbon on the left, 6 oxygens right here, plus 3 is 9. We got 1 calcium, and for nitrogen, we have 2 of them. Jump over to the other side, 1 potassium, 1 carbon, 6 oxygens, 1 calcium, and 1 nitrate. This is actually a great example of when you can keep your polyatomics as a group if you like to, but I kind of tend to not do it that way. So the first thing I'm going to look at balancing here is I'm going to actually jump to my my nitrogen. It's a great place to start. So I get 2 nitrogens on the left, get 2 nitrogens on the right. I would put a 2 there. That will change my potassium to 2, my nitrogen to 2, 6 oxygens here plus 3 here, changes that to 9. So I've got 2, 1, 9, 1, 2. All set. Here are a few to try on your own. Pause them, give them a try, and then I'll work through them as soon as you've had a chance to get them done. So for the first one, we have regular sodium reacting with, so it's just the sodium, nothing else, reacts with this plus sign. Zinc chloride, Zn is +2, Cl -1, so that's ZnCl2. To form zinc solid, which is just regular zinc, and sodium chloride, Na +1, Cl -1. Oops, I've got my 2 right there. So I am going to have to balance out those chlorines. In order to do that, I'll put a 2 right here. That gives me 2 chlorines over there. Now I got to have 2 sodiums over here. Ammonia. NH3 is decomposed into hydrogen and nitrogen. It's important to understand that these are both diatomics. So you're tying in that knowledge of your diatomics. In order to balance these guys out, I'm going to need to end up with 2 nitrogens. So I'll put a 2 in front of this guy right here. That balances my nitrogen. Now I have 6 hydrogens on the left, so I get a 3 right there. Ammonium sulfate. Ammonium and sulfate. So I'm actually going to write down my 2 right there. And barium chloride, Ba is +2, Cl -1, so BaCl2. React to form ammonium chloride, NH4 +1 and Cl -1, so that works out nicely. And barium sulfate, So barium is +2, and sulfate is -2. So that'll work out nicely to Ba. There's no parentheses needed on this guy. SO4. So what jumps out at me here is I have 2 groups of ammonium on the left side and only 1 on the right side. So also chlorine kind of jumps out at me as having 2 on the left side and only 1 on the right side. So I'm going to put a 2 right there. That takes care of my chlorine, takes care of my ammonium. Everything else at this point is balanced. So we're all set.